Okay, it's a couple minutes after 12 and it looks like everybody's here. So let's get this kicked off. Everybody should be seeing a screen called the AI pyramid. And because we're in presentation mode in PowerPoint, you're not going to see the background webinar. I don't know why it is that way, but it is that way. So we're just going to go through what we might call the building blocks of artificial intelligence. We'll go through them one at a time. We'll give each one of these blocks a definition, and then we'll get into some real world applications. But before we do that, when you see diagrams that explain artificial intelligence, quite often it's circles. It's a smaller circle nested inside a bigger circle, which is nested inside a bigger circle. I have no problem with that visual representation of the technology. But the reason I like this particular method, or approach, is because I think it more clearly illustrates how each successive layer of a more and more complicated AI technology and application absolutely depends on the ones below it. And we're going to talk about that in just a few minutes. So I like the pyramid. The way this pyramid idea came about is I was writing content with Claude's help, and then I was putting that content into gamma.app, and gamma.app came back with a pyramid structure. But the funny thing is I'm looking at the pyramid and I'm thinking they have it upside down. They have this in the reverse order. And I put that pyramid into Claude, and Claude said, "Yeah, that's backwards." So we turned the pyramid around and we started to build our AI pyramid. And we start at the bottom with, oh, come on, there we go. Computer systems that automatically learn patterns and improve from experience without being explicitly programmed by algorithms. In other words, machine learning. Machine learning is the foundation building block of all AI applications. You can't climb the pyramid, you can't get into more complex AI tools without having machine learning at the very base of what you're doing. And this really is old. These concepts, this whole idea of having a machine that can think even crudely the way the human brain thinks, this idea goes back to the 40s and 50s. This isn't new, but it took decades for algorithms to get sophisticated enough, computer power to get strong enough, for us to learn enough about how to go about doing this, to even put the basic steps in place. And the basic step is machine learning. Now, as you go up the pyramid, you get to neural networks and deep learning. Think of neural networks as one layer. It's a computational system that consists of interconnected nodes or neurons, which we might refer to in the human brain, organized in layers to recognize patterns in data. But the reason we list deep learning in this same block is it is a subset of neural networks. Deep, in other words, when the neural networks have successive layers that go down and down and down, we call that deep learning. All deep learning requires a neural network. Not all neural networks are deep learning, and the difference is the layers. It's also important to notice that this is the block, this is the level at which there was a deliberate attempt to try to at least copy, even crudely, decision making and data analysis the way the human brain works. So keep going up the pyramid. We get to expert systems. These are specialized computer programs that mimic human expertise in specific areas by using a knowledge base of facts and rules combined with an inference engine to solve complex problems and provide explainable decisions. Well, what does all that mean? It means when you see a doctor using a AI tool for a diagnosis, he's using, as we say here, specific areas using a knowledge base of facts. That expert system has a knowledge base in that specific area of medicine. This also can be used in finance. No doubt it will eventually be used in legal matters eventually. So these are very specific systems, expert systems. In our series AI 101, we go into expert systems in some detail and explain their pros and cons. But they're at this middle portion of the pyramid, and without them, you couldn't do natural language processing. This is a field of artificial intelligence that enables computers, to understand, interpret, generate, and respond to human language in a way that is both meaningful and useful. What does all that mean? Well, it's like when we talk to Siri or talk to Alexa, and it can understand to some degree. It's still in the early stages. It will, in my opinion, it's going to get scary good. Um, but it can interpret what we're asking it, and it can come back with a response and then interpret our question based on its response. Neural language processing. Um, but that is a very important building block. Sorry about that, folks. Going the wrong way. There we are. Computer vision, enabling computers to interpret and understand visual information from the world, such as images and videos, allowing machines to identify objects, recognize patterns, track movements, and make decisions on visual data. Well, what does all that mean? Um, in a way, we've already seen it, although we're going to talk more in AI robotics. But um, for now, we'll just say that when you see those 18-wheelers that have a driver behind the wheel, but they're not driving, and the truck is starting to move itself from one lane to another or not move to another lane because it can see the other cars and trucks around it, all that requires computer vision. And then as we continue to go up, we finally get to the top of the pyramid. AI robotics is the integration of AI algorithms with physical robotic systems, enabling machines to perceive their environment, make autonomous decisions, learn from experiences, and perform complex tasks with adaptability and precision in the physical world. What does all that mean? Well, we'll stick with, because we brought it up already, we'll stick with the example of the 18-wheelers or any autonomous vehicles that are, we don't think of them as robots, but in a very real sense they are. And they're taking in endless amounts of data all around it so that it can do proactive, complex tasks with adaptability and precision, like changing lanes at 65 miles an hour without hitting anything around it. I don't know how many of you know this, but the NVIDIA computer sitting in the dashboard of autonomous vehicles does 350 trillion, that's with a T, 350 trillion calculations per second. What I get so blown away by that is, if you're old enough to remember, which I am, and several people on this call are, mainframes were so big they took their own rooms with drop ceilings and fire suppression systems and raised flooring and all kinds of cabling. And they couldn't come anywhere near 350 trillion calculations per second. But now you can put a computer small enough in the dashboard of your car or your truck that does that. Just stunning. So this is, as of today, we could do this presentation 6 or 12 months from now and might have a different AI pyramid. So think of this as a snapshot of artificial intelligence today. Now, what are some actual examples of this? Well, with the machine learning, you have Netflix's recommendation systems. And this is something we're all very familiar with. If you subscribe to Netflix and you have a certain amount of time using it, getting their streaming content, it comes back and starts to recommend programming similar to what you've already been watching, based on how often you watch. Do you watch dramas, comedies, documentaries? But Netflix, for better or for worse, is watching you. So it's always coming back, recommending things it might thinks you like based on your previous viewing history. Now, if you think about what I said about machine learning at the beginning there a few minutes ago, I said analyzing large amounts of data and extracting a pattern. Well, in this case, the data is our viewing habits, and then out of the viewing habits, it notices a pattern, and then it comes back and makes the recommendation. So whether we knew it or not, we've been using machine learning if you're a Netflix subscriber. So going up the pyramid, Google Voice Assistant. Now this could be any AI assistant, voice assistant, but we'll go with Google's. Um, it can understand your voice. It can respond to your voice. It can respond in context. That's not possible without neural networks and deep learning, which is a series of endlessly connected, what we call nodes in the algorithm, that constantly compare bits of data to other bits of data. It can get very, very technical, but this is how it knows to listen to your voice, place your words into a context, compare it to a staggering number of possibilities, and then respond. Moving up the pyramid, we get to expert systems, rule-based decision making. So IBM has a platform called IBM Operational Design Manager. This is a subscription platform built by IBM. One example is for financial institutions to be able to use it. Now, this is, remember we said expert systems contain specialized knowledge on a given topic. On this case, it would be financial regulations, SEC guidelines, risk assessment, tracking fraud. So when enormous amounts of financial data being used by a bank, a trading floor, a credit card company, enormous amounts of financial data come streaming in from different sources, the IBM operational decision maker has expertise in that domain, finance, and can help a manager, a director, a CEO make better decisions. It's really important to stress you wouldn't rely on it solely. This is a tool, and in the end, we're responsible for how the tool gets used. Climbing up the pyramid to a bridge. What's a bridge? So a bridge, and I believe I was on a medical appointment just 3 or 4 months ago where I think this was being used. A bridge is a tool for doctors, an AI tool that with your consent, with the patient's consent, allows your conversation to be recorded, but not just recorded, understood. So then it can place the conversation into the patient's notes, to your chart, quote unquote. This saves a physician an enormous amount of time, but when the physician goes back to it, it's a more interactive tool for them to talk about diagnosis, to talk about your appointment, to make suggestions about other notes. By one account, tools like these can save physicians 50% of their time from writing notes into a file, a patient's chart, which means they can see more patients in a day. Hopefully, over time, improving the quality of care. It's real important to notice here, though, that when I was on that doctor's appointment months ago using either this tool or one just like it, the doctor asked me first if I was consenting to it, which obviously I did. Amazon's Just Walk Out for computer vision. I haven't been in one of these retail outlets, but apparently the computer vision is so attuned in this retail space that it can track your movements, creepy or not, and you take something off the shelf, you look at it, it knows if you put it back on the shelf or did you put it in your cart. And if it did, it starts tallying up your bill. And so you walk around the store, maybe you've taken a few things, put it in your cart. As you start to just walk out, it automatically bills your card. I'm assuming there's there's a security person there at the front of the store, but there'd be no cash register, which means there'd probably be no cashier. But that is a very sophisticated application of computer vision. And then finally, we get to the top of the pyramid, robots. Now, we could come up with any number of examples of AI robotics, but I find this one so interesting because we are absolutely not far from an 18-wheeler without a driver backing up to a loading dock. AI robots will open up the back of the truck, will scan what's there, start to unload pallets, put them in the right place in the warehouse, or it will scan what's in the truck and start to load the truck. It will take pallets off of shelves and put them in. Being very, very aware of weight distribution, which is crucially important in an 18-wheeler. Now, What does this do for jobs? I don't know, but but they're going to be impacted. My own opinion is that the biggest impact AI will have on the workforce is where manual labor is the is the most dependent upon. There's a saying: you're not going to lose your job to AI. You'll lose your job to the person who knows how to use AI. I think that's true in your more white collar office environments. I don't see it, and probably in some factory environments, but in straight things like warehousing, putting things up on shelves, taking them off shelves, using a forklift, using a pallet jack. No, I think you lose your job to an AI robot, and I don't know how many people will still need to be in that environment. So, trying to keep this in context, what I'm trying to communicate here is how each technology going up the pyramid is requiring the one below it. It's also why I prefer this diagram to the ones in the circles. So Netflix recommendation systems, it's just machine learning. If you want to write Google Assistant, if you want to write that kind of application, well, you're going to write it with neural networks and deep learning. But you can't do it without machine learning down below. IBM Operational Decision Maker. You need expert knowledge in a specific domain like healthcare, like finance, and I'm very confident eventually the law. So we're going to write this expert system. Well, not without neural networks and deep learning below that, and not without machine learning below neural networks and deep learning. We want to write healthcare applications like a bridge that requires natural language processing. Go to it. Except you're going to need expert systems below your NLP, and below your NLP, you'll need neural networks and deep learning, and below your deep learning, you'll need machine learning, and then up to computer vision, you need all those steps before it, and then you get to AI robotics, and hey, knock yourself out. Have a great time. Build robots that can do amazing things, but you're not going to do it without computer vision, and you're not going to get to computer vision without natural language processing, which you're not going to get to without expert systems, which you're not going to get to without neural networks and deep learning, which you're not going to get to without machine learning. All these blocks build on top of one after the other. Now, it's very, very important to remember that all AI technologies can be wrong. This is really important. And a great example of how they can be wrong came up when I was doing this pyramid. I asked Claude, I did some of this content in Claude as I was writing this out and double checking it. Give me an example of something for expert systems. And it came back with this healthcare application called, I assume this is pronounced Mycin. Well, that seems kind of strange. Mycin, what's Mycin? Now I know from experience and things I've read that these LLMs can make things up. They can use references that are completely out of context. So I looked up Mycin because I'd never heard of it. You always want to do this. And it came back, this is Google. Mycin was developed over 5 or 6 years in the early 1970s at Stanford University. It was written in Lisp. I think Lisp was a computing language, I think, as a doctoral dissertation of someone named Edward Shortlife under the direction of Bruce G. Buchanan, Stanley and Cohen, and others. This was a PhD candidate, Edward Shortlife, writing his doctoral dissertation. Well, in the 1970s, 50 years ago. So how absurd would it be to use it as an example of expert systems? Only because I know that you cannot just take what these LLMs say lock, stock, and barrel. I went and checked on that. And then we found a much better example using the IBM operational platform. The bizarre thing is the IBM reference is new. I mean, it's contemporary. Why did Claude go back 50 years? I don't know. To an early hypothetical concept of expert systems? I don't know why it did that. The other odd thing is Mycin was never actually put into practice. And it couldn't. I don't even know if they tried. But if they tried, I'm sure it failed because computing power simply wasn't strong enough at that time. So always remember that AI technologies can always be wrong. Now, by tomorrow, this AI pyramid could be obsolete. And what I mean by that is the AI industry is developing so fast that if we were to do this presentation again in 6 months, certainly a year, maybe there's something new at the very top, or maybe there's a new layer that gets stuck into the middle that now becomes an important part of this chain of technology, if you will. So think of the AI pyramid as a snapshot. This is this is how you might look at artificial intelligence today. Say this is not one thing, it's a series of interconnected technologies, and the more sophisticated, the more complicated your your AI application gets, the higher up you go on the pyramid, but the more you rely on the quote unquote simpler, if you think about applying that word, to the AI technologies below. So this is a snapshot. It's an AI snapshot of today. It will undoubtedly change in the coming years. So, Bill McLean, yes, Bill, I completely agree. The only reason there isn't a top, something above AI robotics is we haven't thought of it yet. Are we going to think of it? Yeah, probably. which gets into what I'm saying about this is today's snapshot. A year from now, this could be wholly different. So, okay, it looks like there are no other comments or questions. This has been the AI Weekly Webinar at the AI Conversation. Check us out at theAIconversation.com, the online community where all of us together will figure out how to use and how to work with AI tools. Okay, best to all, and thanks very much for joining.